Hello and welcome. This video will solve some of the problems on types of functions. So here we have a function f of x is equal to x plus mod x. We need to check what type of function is this. So what I do is I'll take this as f1 of x and I'll take this as f2 of x. So f1 of x is, I'll write this as f1 of x is, it is x from minus infinity to 0 and x from 0 to infinity. I'll tell you why I've written like this. So what I have written f1 of x into two parts because f2 of x can be written in the same form. So we know that mod x is equal to minus x when x is negative, and it is plus x when x is positive, when x is positive. So now it is easy to add these two functions. That's why I have defined f1 of x in the piecewise format. So if I add these two, I'll get f of x. So f of x is actually f1 of x plus f2 of x. So which is can write here, from minus infinity to 0 we have x here, from minus infinity to 0 we have minus x here. So x minus x is 0. This is from minus infinity to 0, and from 0 to infinity we have x here and x here, so it is 2x. So from 0 to infinity it is 2x. So this is my f of x. So if I plot f of x, so I get 0 from minus infinity to, let me write it properly, 0 from minus infinity to 0. This is my 0, and it is 2x. 2x is a straight line from 0 to infinity. So this is my y, this is my x, 1 2 minus 1 minus 2 minus 3 and so on. So to check whether it is 1 1 or onto, what we do is we take a horizontal line and we move this through the function, and we'll see uh, how many times this horizontal line touches the function at any point. So if I bring this up to here, you can see this horizontal line is touching the function at many points. It means f of minus 1, f of minus 2, or any value of minus infinity, it's all 0. So it is many to 1. It is many to 1. It's not 1 to 1. It is not 1 to 1. So this is not 1 to 1, and this also we can uh, neglect because it is not 1 to 1. And to check onto we need to check how many values the function is covering in the y axis. So in the y axis it is covering only from 0 to infinity, but it does not take, f of x does not take value from minus infinity to 0. That is why it is not onto as well, not onto as well. So this is neither 1 1 nor onto. So this function f of x can also be asked as like this: f of x is equal to x plus square root of x square. So this is same as this one. So f of x plus square root of x square and f of x plus mod x are both same. So this function is neither 1 1 nor onto on real numbers. So this is important. There is another way to plot this. Directly we can plot like we have f of x is equal to x plus mod x. So let us plot these two. So I'll take this as again f1 of x, and I'll take this as f2 of x. So if I plot this, I'll plot f1 of x plus first. f1 of x is actually this function x. X is a straight line passing through origin like this. This is my This is my f1 of x, which is x. Next I'll take mod x. Mod x, we know it looks like this. Then this is actually f2 of x, which is mod x. Let us add these two. So if I add these two, we can clearly see let me write it properly. So here in f1 of x, this is the negative part and the same positive part is here. So when I add negative part with positive part, we'll get 0. At every point it is 0, like this. Then here I have x and here also I have x. So if I add these two, x plus x becomes 2x. So I'll get a straight line with slope 2. So now we can clearly see it is not 1 1, not 1 1, and not onto as well, because many values of x giving 0, that is f of minus 1, or if x is less than 0, f of x is 0. So this implies it is many to 1, and the function is not covering the values from minus infinity to plus infinity, and it is covering only from 0 to infinity, and it is not onto as well. Thank you.